Recording here. All right, welcome to week 2 of Algebra 1. And today we've learned a lot about expressions and how to do algebraic addition and manipulation of expressions. Okay. We also had some lessons on exponents. Let me share the screen and show you some of the assignments that I've seen here from you. Okay. Let me put the screens on the right place here. Okay. And are there any questions about the lesson, about the things that you are doing so far? Okay. So, SB, excellent job here. Very, very nicely done with your assignment. I love that you took notes on everything, including the readings of the algebra for the practical man. I'm going to try to include more of those as I find them. Okay. And we have the PDF, all right, there. So I was a little hesitant to require the textbook, but we'll see how it goes. Okay. And then these are Caleb's notes, also very good, clearly written. I love that. Okay. This is very interesting and very good, Caleb, that you indicate why it counted it wrong. Okay, so it's important to whenever I make a mistake, all right, and I get a problem wrong, I try to figure out, okay, what was it that I did wrong? Okay, and I learn more from my mistakes than anything else, really. So very, very good. I don't want you to take notes on the computer. Okay. I don't know. I don't remember which ones are these, but typing mathematics on the computer is very, very time consuming, very difficult to do. And pretty soon it's going to get to the point where you are not going to be able to do it. This is just one problem. Okay, imagine how long it would take to do all the problems that way. And so, really follow, believe me, it's a lot easier, more efficient, and better to do it the way that I suggest. Get a notebook, do it by hand. All right. The question that I have here is you do not use x for multiplication because it looks too much like the variable x. Why is there not another symbol for the plus sign? Because it looks like a t. Well, they look similar, but they are different enough that mathematicians have basically decided, we'll keep the add sign, okay, and keep the t. So t is not too often used as a variable, okay. It is used a lot in physics, in engineering, because it's we use it for time, okay, the t, but it is different enough that it should be all right. Kyron, good notes. I just recommend that you use the pages a little bit more efficiently, because if not, you are going to end up with 30 notebooks for the school year. Okay, but very nice. And then Glenn, I don't see Glenn here, but these are kind of like minimal notes. I don't know. No, Glenn used to take more notes. And then here, Vincent, good job with this. When you make a mistake or something, don't scratch it like this. Just, you can cross it, okay? And you can even indicate what was wrong. Okay, and try to be very, very neat. All right, let me see. I have a couple of other notes on uh, on documents. I think that this is Brina's. Are these yours? Yeah, excellent. Very nicely done. Okay. When you take the pictures, if you can try to take them a little bit more from the top, so I can read the top part also, that would be great. But good work with that. And then let me see these other ones. Trend, excellent work also here. Very nice. Most of you have taken really nice detailed notes. So great job with that. Okay. The only ones that I couldn't see. Okay, so let me see in here. I couldn't see Ethan's, I think. And let's see the comments. There were a couple that were not shared correctly. So Brigham, okay, you need to share the correct share link. Okay, remember that. And then Ethan also the same thing. I don't want to request access or anything like that, but all right, good. So we are doing great here. Any Ethan is now coming, I think, to the lesson. Okay. Any questions about this? So Ethan, I was just saying that you need to share the link here that will give me access directly. Okay, you know how to do that? Mm-hmm. No? Okay. So if you go to your Google document, you click here on share, all right? And you need to click in here that anyone with the link is a viewer, and then you share that link. Okay, so we don't need to ask permission for the document. Okay, excellent. All right. Well, questions, comments about the lesson today or anything? Brigham? Mm-hmm.
I had a question in my notes, but since you couldn't see it, you didn't see the question. So,
That's right.
it in the algebra for the practical man, it's talking about transposing terms. I didn't really understand that. Like when you
Okay, let's
switch it to
go
the other
and
side.
see that. Okay, let's go to, I'm going to actually bring the, let's open the PDF. Okay, since we have it. What page is it? What page is it, Brigham? Mm-hmm. Brigham, you are muted.
It was a 95.
95. Okay, so let's go. Let's go to 95. It's probably going to be a few pages after that. Okay, yeah, so let's do, okay. And okay. All right, 92, 93, 94, 95. Are we on the right page here? Mm-hmm.
Yeah.
Okay. All right. Okay. So you can unmute yourself and have the camera on at the same time, but
Yeah, my
all right. So
camera's
let.
like not
Mhm.
working for some reason. It's
Oh, it
like,
was working fine before. Yeah,
oh,
it's
okay.
it's okay. Yeah, you're all right. Mhm. So which part is it here that we are talking about? This?
It was down in where it talks about the 4y and plus 7 equals 14 minus 3y, and then it like switches the 3y to the opposite side.
Okay. Uh-huh. This part?
Yes.
Yeah. Okay. All right. So the principle here is as any term in either member of an equation may be transposed to the opposite member provided its sign is changed. Okay. All right. So let's see how this works. All right. So let me, first of all, we need to use the words very, very carefully, okay, here. Okay, so here we have, for example, four, okay, so 12, let's undo that. We have 4y plus 7 equals 14 minus 3y. Okay, that is what we have right here, you know. And so let's identify things and name them correctly. Okay. All right. So first of all, we have what is a member? Okay, so here it talks about a member. What is the member? All right. Any idea of what is the meaning of that word, member? SP?
In my notes, it says the two parts of an equation which are connected by the equal sign.
That's right. Okay, so the two parts of the equation, okay, that are separated by the equal side are called members. So this could be called the left member and the right member. Sorry for writing over the other thing. Okay. But does that make sense? All right. Sometimes nowadays we call that the side of the equation, the left side and the right side. But the technical term is really the member of the equation. Yeah. Okay. So then we have another word is terms. Okay. So we have term. What is a term? What is a term in mathematics, in algebra? What is a term? Caleb?
It's anything that's divided by an addition or subtraction sign.
That's right, yes. Anything that is separated. Let's use the word separated instead of divided, because divided has a different meaning here. Okay, so anything that is separated by an addition or subtraction sign. Okay, so here we have the terms, all right, the terms of this equation. So this equation has two members. Every equation has two members. Okay, each member has two terms. So we have four terms in total. All right, so these are the terms. Okay, all right. Notice that the sign, okay, the sign follows the term. All right. When you have no sign before the term, what do we assume? What do we assume when, like, for example, here 4y and 14?
That it's positive.
That's right, yeah. So we are assuming here a positive sign, okay? So we are assuming that. So far, so good? Yeah, Melanie, are we okay? Yeah. All right. Great. Okay. Now, what other things can we have here? Now we are going to talk about the words. It's not talking here about that, but we can talk about the word factors. What is a factor? Okay. What is a factor? Mhm. So we talk that the members are separated by the equal sign. The terms are separated by the plus or minus sign. What are the factors? Mhm. Think, so we have the equal sign separates the members. The plus and minus sign separates the terms. What do you think that could separate the factors? Okay, or what are the factors? Mhm. Let's see. Trent and Ali? Mhm.
The multiplication and division.
Yes, yeah. So anything that is separated or implied by a multiplication or division, okay, is a factor. Okay. So this is important. So here we have that this term, the term 4y, has two factors. Okay. This term, we can say that it has the factor of plus 1 times 7. Okay, the 1 is always implied, but we can just say it has just one factor. Okay, the 14 is also one factor. And then here, you can think of minus 3y. Okay, you can think of minus 3y as two factors. Either you can think of this as minus 3 times y, or you can actually think of this as minus 1 times positive 3 times y. Three factors. Okay, however you want them. All right. Yeah. So far, so good. Okay. What about if I write something like y over 2? How many factors do I have here?
2, right?
Tell me what they are. Mhm.
Y and 2.
Okay, so it would be like y times 1/2. Okay, all
Okay.
right. You see it there? Okay, so you see that the factor here now, because we define the factor as anything that is separated by multiplication or division. Okay, so the division, usually in algebra, we write it like a fraction, okay, but it is really that way. All right, okay. So now, to go even further about naming of things and everything, we have that the factors can be further named in two ways. We can have coefficients, and variables. Okay. What is a coefficient and what is a variable? What is a coefficient and what is a variable? Jace?
A variable is is a letter in place of a number, whether it's unknown or just to not have to rewrite the number multiple times.
Mhm.
And a coefficient is the to the power of, where it's a symbol that represents multiply this number this many times times itself.
Oh, okay. So that is actually called the exponent.
Oh, right. Sorry. The coefficient is the multiplier. Something
That's
that
right.
multiplies to something. Yeah, that's it.
Okay, so the coefficient, like for example, in this case, the coefficient could be the -1 or the 3 or the -3 is a coefficient, okay? The variables are the letters, okay? And because the letters can change value, they vary. They change value, so they vary, okay? The coefficients are the things that are multiplying things, okay, that do not change value in the equation. Okay, so we have the coefficients here, 1/2, okay, and so on. So far, so good. Are we okay now here with all the naming of things? Okay. All right. So Ethan, I'm going to get your question in a second after we finish. I haven't forgotten you. Okay. So all right. Don't forget the question. So, all right. So here we have that any term in either member of an equation may be transposed. What do you think that it means here by the word transpose? Okay. What is transpose? Bridger?
Move.
Moved. Yeah, that's right. Thank you, Bridger, for all the one word answer. Moved. Okay. So they can be why didn't they put here moved? Instead of being so fancy, okay, transpose, okay, everything.
That's what I'm
But
saying.
that's right. Yeah, yeah. So move, okay, to the opposite member, to the other member, provided its sign is changed. This is the important thing, okay? And so if I have a term, okay, if I have a term here, all right, and I have minus something, okay, and equals this, okay, I can move this term, to the other side of the other member of the equation, but I need to now change the sign of it. So I'm going to end up with this minus, okay, something like that. Okay, and then this is going to be minus, okay. Yeah, all right. So that is actually very, very critical, to understand that we move terms from one member to the other by changing the sign of the member of the term. Okay, so of the term. Yeah. Why is that? Why does that work? In math nowadays, in Khan Academy and everything, they always take kind of an intermediate step to explain how this works. The intermediate step of doing that is that if we modify the equation on one side, if we do something to one member and we do it to the other member, then the equation remains the same. Okay, so what this is implying here is that we are going to, subtract this from both sides of the equation. Okay. We are subtracting from both sides of the equation. And so if I add and subtract the same thing, that is equal to 0. Yeah? If I add 5 and subtract 5, I'm going to end up with 0. And so that is what allows us to basically say, okay, yeah, this cancels that. And now we end up with that term on the other side, on the other member of the equation, with a different sign. Okay. So this is kind of the why it works. Yeah. In Khan Academy videos and everything, you are going to see that Salman Khan almost always takes this intermediate step in order to help you understand what is going on. Okay. In more classical mathematics, they use basically this principle. You just move the term, transpose the term to the other member, okay, of the equation, change the sign, okay? So if something is positive, it'll end up negative. If it's negative, it'll end up positive on the other member. Okay, so here we have 4y plus 7 equals 14 minus 3y. So it says, let us transpose, okay, the member minus 3y. The result is that we just move that term, now positive, to the left member of the equation. Okay? And then it's going to say, in this equation, let us transpose the plus 7. And so we transpose the plus 7 to the other member as a minus 7. All right. Why does it do this? Why do we transpose the minus 3y and the plus 7? Caleb?
So that we can combine like terms.
Exactly, yes. So now we have that two terms, the plus 4y plus 7y, they are similar terms. They are like terms. Similar terms means terms that have the same variables in them, okay? All right. And then these other two terms are also similar terms. They don't have variables. They are just constant. Okay. And so we can now add them or subtract them algebraically, and we end up with 7y equals 7. Okay. Yeah. All right. So now the other thing, the other operation that we can do, and is also very important, is how do we transpose factors, okay, from one member. So if I have like I have here, I have 7y equals 7. Okay. Here I'm going to have, on the left member, I have one term with two factors, the 7 coefficient and the y variable. Yeah? How do I transpose factors from one member to the other member? When we are talking about terms, we change the sign. When we are doing factors, we need to basically do the inverse, okay? Okay, the reciprocal is called, okay? The reciprocal. All right, so the reciprocal of 7, the reciprocal of the number 7 is 1/7. Okay, I'm dividing that. What would be the reciprocal of 1/2? What is the reciprocal? Trent?
2.
That's right. The reciprocal of 1/2 is 2. Okay. And so if I want to move this factor, this 7 here, this 7 here, I can move it to the other side of the equation by doing the reciprocal. So it's going to be y equals 7, that is this 7 there, times 1/7. Okay. And so factors, I move them by doing the reciprocal operation. Terms, I move them by switching the sign of the term. All right. What is the intermediate step that, again, in Khan Academy, they always are taking the intermediate step to indicate what is it that we are doing to both members in order to move a factor to the other side of the equation, to the other member. We are basically going to say, let's divide, okay, both sides of the equation by 7. Okay, and so of course, 7 divided 7 is 1. All right, so we are kind of getting rid of that. And now we end up with 7, over 7 over times 1 over 7 on the other member of the equation. Okay. Yeah. So remember that this is very critical to understand, because we are going to be moving things around on these equations a lot. And so we need to understand how this works. Leila, are you okay with this? Yeah? So far so good? Okay. Now, Brigham, did we answer your question on what is it that is happening here? Okay. We probably answered more than you wanted, okay? You were like, whoa, okay. So, but is this is really, really critical and important. Let's be very precise when we use the words member, terms, factors, coefficients, variables, okay, exponents. Okay, so let's go and talk. And Jace, explain to us about exponents. What are they? Okay.
Exponents are they're represented by small numbers above like the individual numbers, telling you how many times to multiply that number by itself.
Excellent. Okay, and so if I say x to the second power, okay, this is the exponent. What is it called? This other number, the x. What would that be called?
That's a variable.
Yeah, that is the variable, but
And the coefficient.
yeah, in terms of the operations of power and exponents, it has also another little name. Okay, Caleb, do you remember?
I think so. It's called the base.
The base. Okay, the base. Okay, because this is basically telling us what is it that we need to multiply that many times. Okay. So the base. The base could be, it could be an expression. Okay, so I could have y plus 2, all in parentheses, to the second power. All right. So the whole thing is now the base. The whole expression y plus 2 is the base for that. Got it? Okay. I hope that you have taken really nice, good notes about this, because this is not trivial. Okay, so Trent is thinking, I took notes right here. Yeah. It's like, okay, good. So try to remember to actually write these things down even during the class or after class, but that is an important practice, since we are doing this. So let's I think that we have beaten this horse, okay, quite dead. Yeah. All right. So we'll call it done. Okay. So, and then let's see, Ethan, your question.
Are you still not receiving the lessons fully? Because last time I looked at your chart, it said they weren't checked off on my thing, but I've been doing them. So I'm not sure.
In Khan Academy? Let's check. Let's check that and see. I'm going to go here to my other screen. And let's see. I'm not going to show the screen because if I do, then I need to edit the recording because YouTube doesn't like it and so on. It's a big hassle. Okay, so but let me check and see. All right, I see Abigail's area. Oh no, this is sorry, this is the wrong class. Okay, that algebra 1. I was looking at the pre-algebra class. So sorry guys. Okay, let's take a look. Okay, I see Ainsley. Well, I don't see her. Okay, Ali, I see yours. Okay. Ali Hatch. Talon. Bridger, I don't see yours. Okay. So make sure, Bridger, that you log in into your account. Okay. We have Bridger is an empty chair now. All right, let's see. So Bridger, I don't see your assignments completed in Khan Academy. Okay. So make sure that you are logged in when you do them. Brigham, the same thing. I don't see yours. I see Brigham Law. So Brigham Schmutz. Is that how you say it? Okay. All right. So I don't see your assignments, but I see Brigham Law. I see Brina, Caleb Gallagher, Caleb Manuel. I see Sam. No, it's kind of spotty. SP, yes. Ethan, I see some of yours. Okay. All right. So I see the quiz 1 of algebra, and then some videos. I don't see some of the exercises. Okay. So, all right. Glenn, I see yours. Jace, I just see your quiz 1. Okay, but not further. So let's just make sure that you complete the whole thing. Kyron, I see everything. Layla, I also see quiz 1. Mason, I see some of yours. Melanie, I see some of the exercises. Here we have someone called Page Libros 2020 that I don't know who that is. Okay. Riker, a few videos. Samuel, I see a few of the exercises, but not everything. Okay. Brand, I see pretty much everything. Jackson, none. And Vincent, I see everything in yours. Okay. Sam?
I didn't get all of them done yet. I was on a hunting trip this weekend, and
All
we
right.
stayed an extra day yesterday, so I wasn't able to get all my homework done, but I'll catch up on it.
Okay. Excellent. What were you hunting? Did you catch anything?
Not this time. We were going out for mule deer. It was an early season archery tag.
Okay. Archery. All right. Well, that is the you really give the animal a fair chance. Okay, with archery, it's really very much a hunt there. So good, great. Okay. Well, so Ethan, did we answer your question? Yeah. Okay.
Should I send like a picture if the other stuff doesn't pop up that I did?
No, not necessarily. So this is the interesting thing. Okay. I see your progress in your notes. Okay, so if you write your notes, writing the solutions to the problems, and then you tell me, yeah, I'm doing this, then I'm like, oh yeah, I can see that is being done, that is getting done. See, for example, let me share an example of an experienced student here, SP. Okay, she survived pre-algebra with me last year. Okay, and so her notes here, they are, very complete, and also she is putting here even the title of the lesson, the Khan Academy lesson that is happening. I can see that she is doing the Khan Academy exercises. Why? Because, oh well, they are right there. Okay, so you see, I see now taking notes from the reading assignments, and then this one is even telling me, oh, this is quiz 2. Okay, great. Even with the score, I don't even need to log in into Khan Academy to see that. Mm-hmm. All right. So this is proof enough that, yeah, this is happening. Okay. The Khan Academy score over on in the software is all more for you and really to keep track of things and so on. If I see someone that is not doing anything, I'm not seeing the notes being taken, then I'm assume that nothing is happening. Okay. Does that make sense? Mm-hmm.
Yeah, and my notes are kind of small because there's this thing I use on the Khan Academy website that like gives you a pen and you can write it down on there.
Uh-huh. Yeah, I use that once in a while, but I actually prefer and highly recommend that you take notes on a notebook, because then that becomes your notes. You can keep those. If you write them on the screen, then it's gone. Once you go to the next problem, you lose everything. Instead, if you keep your notes, you can always refer back to them. Kyron?
I was wondering, this is rather a side note, so maybe you can wait till after class. Should it wait till after class or?
I don't know. Let's see. Let's have it, and I'll tell you if we wait after or what.
So, does the whole idea with earth science level of notes
Mhm. For that,
differ
we'll
from
wait after
algebra?
class, because that is for another class. So let's wait right after class, Kyron. Because if it's about another class, that would be more fair. Okay. So are we getting into the groove about what is it? What are the expectations on the notes and everything? Okay. We had a very useful discussion here about the nomenclature of words in algebra. So we are starting to identify members. What are the words that we define here? Okay, who can tell me all the words that we define in this class so far? The vocabulary. Okay, Jace, go for it.
Okay, so we define term, which is there are parts of the equation that can be separated by plus and minus signs and the multiplication and division signs. There's members, which are separated by the equal sign and the sides of the things. Then there's transpose, which is just moved. Then there's the coefficient, and which is the multiplier, the variables, which are the letters standing in for numbers, and then there's the exponents, which are the multiplier thing to the power of, and then there's the bases, which are what it's multiplying to the power of, and I think that's all I got. So
There's one correction that we need to make here to your notes. Okay. Who notice what is missing and what would be the correction? Anything that jumped to you? Okay. So Jace, you define the terms. Okay. Let's see if Caleb got it. Let's see what.
So, I'm pretty sure he defined the terms as being separated by plus, minus, times, or division, multiplied or divide signs, and the factors are the ones that are separated by the multiplication and division signs, and the terms are only separated by the plus and minus.
Yeah, I have
That's
this.
right.
I have it written that way. I just read it for some reason the wrong way. Sorry, that's my bad.
No problem, no problem. Excellent. Good, good. So, yeah, but it is important. All right. Now, the interesting thing is that so far, what we have done are really very simple examples of terms and factors and everything. But in algebra, it can get very complicated. Okay, a factor can be a whole expression that is a factor. All right. And so you always have to keep that in mind. What is it that we are talking about and so on? What did you learn about parentheses, brackets, and braces during this week? What did you learn about that, Jace?
Well, I might not have like gotten the entirety of it, but the parentheses, you always solve those first, then you do the brackets, and then you do the braces. And braces kind of enclose the entire expression. Brackets enclose another part of it, and parentheses an even smaller part.
Aha. Okay. So, yeah, so traditionally we have used parentheses, brackets, and braces. All right. And the idea is that you do them in order. Okay, so the innermost is the parentheses, then next is the square brackets, and then the more outside is the squiggly braces. Okay. But what is the main thing about it? Okay, let me see if I can share the screen here and see if we can look at this. So one thing that is important to understand is that we could have something plus something else, and then this in parentheses, and then multiply, let's say, by something else, okay, and then embraces. All right. Okay. And then we can have another thing and, more stuff and so on. And then this would be the, the braces. So brackets, parentheses, brackets, and braces. Okay. Now, what we cannot do is to have something like this, okay, that we have parentheses, and then we have braces like this. All right. What's wrong with that?
It's inside the parentheses.
Yeah, It's inside the parentheses. So the position and order of things is actually very critical and important. Okay. So it is really like layers of an onion, if you think about it. Okay. Now, in computers, all right, since the advent of computers, we have basically stopped using the brackets and the braces for this type of operation. Okay. In some computer languages, we use the brackets and the braces for a different thing, but not for that. And so what we use now is just parentheses. And so we would write this way, and then another parenthesis this way, and then another parenthesis this plus this, and close parenthesis. Okay. Yeah. So you always have to be careful when you are writing the expressions just using the parentheses, is to keep track, okay, that for every open parenthesis, you have to have a close parenthesis. Yeah. So in spreadsheets and in every computer program and everything, we only use just the parentheses now. Okay. So that is something significant to point out. Okay, let's do a Kahoot really fast. Is that okay? All right. So this one, let's go very quickly to the Kahoot. So let me put it. Where are you? Okay, host. Okay, I'll bring it in a second once we generate the thing. Okay, and let's share the screen here. All right. So there we go. Okay. 215702. We'll need to go fast here, guys, because I have to finish the class on time because I have another meeting at 9:30. So let's go and do. This is a simple but fun Kahoot that will review all the things that we've learned here. Are we all there? Anyone else? Caleb, go ahead. We see Mason, Glenn. Caleb, go ahead.
So I just can't figure out how to get out of it's showing me the Kahoot thing and I can't figure out how to get onto my thing so I can search up the Kahoot.
So can you open a browser tab with kahoot.it? Is that
So do I have to leave the meeting to do that?
No, you could. They're in the top left or in the top right, I guess, is the little square that's doubled. Press that, and that should minimize the zoom screen. Then drag the empty space and lift it until you see a higher bar up there. Then it will show you options of what to do, and then you can do split screen. And like you want to do, I prefer the right side, and then you can open another tab in the left.
Got it.
Okay.
wow? Jace, you are a pro at this. That is awesome. I wouldn't have been able to explain it better at all.
I prefer the left side.
You
So
do
what
the
was
same thing. So
what was the game pin?
215.
215702.
Mhm. Yeah, that is great. Okay, there we go. All right, let's get started then. Okay. Let's see the quiz. Can you use all parentheses, brackets, and braces in one expression? That's an interesting question. Okay. Have we all answered? How many do we have? Let's see. We have potentially
We have
18.
18 participants. We need two more.
Two more. Uh-huh.
Yes.
Okay. All right, so 5 seconds. So let's see how this goes. Okay, yes, most of you got it correctly. Yes, but you must have them in order and pair. In order meaning what? What does it mean there in order? Caleb, question, comment?
So it just isn't letting me click on the answer. I was trying to select the yellow one, but it wasn't letting me click on the answer.
So remember that in Kahoot you have one screen that the Zoom screen where you see the question, and then another one where you just see the little squares. Is that what you are seeing?
No.
You have to, so you have to have the other screen where you see the colors for you to answer without the prompts. They don't show the prompt in the response screen. Is that correct? I never play them. I
Yes.
always, host them. So
Oh, okay. Yeah, now I'm in it.
okay, all right,
Now I can see.
good. So let's see. Kyron and Bridger and Ali, super fast there. All right, simplify 3 to the square times 3 to the cube. That'd be all right. So 3 to the fifth. All right, and most everyone got it correctly. Some went for 6 to the fifth. All right. So let's take a look at that. Okay, and so 3 to the square is 3 times 3. And 3 to the cube is 3 times 3 times 3. And then I have a times here in between. So I end up with 3 5 times. Okay, so that is where we have 3 to the fifth power. Okay, you see that we are not multiplying the bases. We don't multiply the bases here. Okay, so it's not like we have 6 to the fifth. No, that would be not correct. That would be very different. Okay. So, Kyron,
I
we
didn't
okay?
do that on purpose.
Uh-huh. Oh, okay. All right. So let's go to the next one. All right. Bridger and SP very fast coming up. Okay. What is the sum of the coefficients in 2x plus 3x? All right, everyone got it correct. Great. So yeah, that's 5. All right, so that would be 5x. All right, but here is asking just for the coefficients. So good, fast alley there. So very close. True or false? The expression 2a plus 3a plus 4b simplifies to 5a plus 4b. Okay, think that everyone answer. Yes, it does. Okay. Yes, it does. That is true. All right. Let's see. All right. SP and Kaino. Okay, we are really just going back and forth here on the. This is a fast quiz here. Multi-select. Which of the following statements are true about equivalent expressions? Okay, that one. This one is a doozy. Which of the following statements are true about equivalent expressions? Okay, 2 more answers. Remember that you need to click submit on this multi-select. You choose your answers and then. Okay, there we go. Okay, so we have these are the correct answers, and most of you got everything correct. Okay. So this one, the red one, is a little tricky, because it's saying they have the same value for the values of each variable. What I understand this to mean is that if you have an expression, wherever you see a variable x, then that variable is going to have the same value throughout the equation. Okay. Does that make sense? So, yes, the value can change, but at any moment, x is always going to represent everywhere the same value. Yeah. So that is what that one means. Okay. They have different numbers of terms. Well, they could, but not necessarily. So it could have, but that is not always true for that. Okay. So good job. Let's see how we go. Ooh, big change in the podium, and Kyron is back on top here. So don't go and celebrate just yet. Okay. So we have two more. The expression 2 plus 3x minus 4y minus 2yx can be simplified further. Okay. Can we simplify this more? That's right. No, you cannot. Why? Why can't you simplify this further? Okay. Kyron?
So the expression cannot be simplified because yx is technically its own independent variable. For y, there's no other y's that are alone. X, no other x's, and 2 is its own. There are no other individual numbers instead of variables.
Yeah. Yes. Is there another way to explain that? Okay. Do you remember the word? Okay, let's see. Ethan, how would you explain it?
There are no other variables. That's not.
There are. How about the word similar? Do you remember about listening, hearing the word similar? Okay. There are no similar terms here. We have 4 terms, but there's no similar terms. Similar means that they have the same variables with the same exponents in the variables. Okay, so there's no similar terms here. Good deal. Let's see now. All right. Ooh, SP coming back up, and Vincent Ali trying to catch up there. The last one, multi-select. Which of the following is a unit of length? Which of the following is a unit of length? Multi-select. Let's see how that goes. Yeah, light years. How is, oh, sorry. How is light years a unit of length? Kyron?
Light years is a unit of length because it is not talking about a time. It is talking, well, technically it is, but but it is talking about the distance that light travels in a year, not the time the light takes to travel. So the
That's
distance the light
right.
travels in a year.
Yes, yeah, so it's a huge astronomical distance. Okay, so good, good deal. Milliliter is a measure of volume. Kilogram
Wait,
is a measure of weight or mass. And second is the measure of time. Okay, or degrees. Okay, of angular measurement. So good deal. So let's see the final podium here. All right, SP in third place. In second place, Caleb Manuel and yeah. Kyron, you maintained the podium there. Good job. Excellent. Bridger and Ali, runners up. There. Good. Good deal. Okay. So let's go and see anything else. I'm going to, good job, guys. Very nice. I'm going to stop the recording here.